so now we would like to consider another interesting problem, and that is the portfolio optimization that can also be mapped into a QUBO problem. Okay, so the problem is the following: we want to maximize the return of some investment. Okay, and the investment is made by means of a portfolio. So the idea is that we have like n different assets and different stocks that we can decide to invest in. And the idea is to determine what's the right amount or the optimal amount of every investment that we would like to compose our portfolios, right? The idea is to maximize the return, but there are some constraints that we need to respect. Okay, one constraint, of course, is that indeed these quantities are, let's say, fractions of my total portfolio. So they have to add sum up to 1, and with the condition that I get a positive number of stocks of every possible asset. Okay, and then the second condition is related to the risk that I want to assume. Okay, this is okay. Let me explain in more detail the quantity that wants to be maximized. Okay, so this is notice that this is the total return. This R vector is the vector of the historical returns, so the mean of the historical returns of every asset. Okay, so R1 is the return that the asset number 1 had in the last 2 years, for instance. Okay, and so on and so forth. Okay, so we want to maximize the return given the constraint that also the risk that is parameterized by these fluctuations here is bounded. Okay, so basically, given a problem, we have to decide the risk that we want to assume, and then the optimization of this quantity will give us which is the maximum return that we can expect, and which composition has this return. Okay, the solution of our problem will be the composition of our portfolio. Okay, so let's understand more this basic part. Okay, so this matrix Q is a matrix that is the covariance matrix. So basically, its diagonal elements correspond to the fluctuations that the different assets had in the past, and the diagonal elements correspond to the correlations. So usually in financial markets, there are like stocks of some companies that are correlated. I don't know. I guess that it's very likely that IBM and D-Wave have a correlation in their stocks. So if there is a hype in the field of quantum technologies, then people will start to buy stocks from these companies. No? So basically, this is the idea. So here there are some comments in order is that notice that this is not a QUBO yet because these values are not binary strings; these are real numbers. Okay. In order to convert this into a QUBO, we first should convert it into integers. So basically, this could be easy. So if we want to have a precision of 10 to the minus 3, we would write here just 1,000, and basically assume that these quantities are integers between 0 and 1,000, and then we could basically apply all the technologies that we have shown to map this into a QUBO. Okay, from mapping integers to QUBO. And the last thing that we have left is just writing the expression, the function that we want to minimize, taking into account the constraints. So basically, the potential of the cost function we would like to minimize will be as follows, right? We want to minimize, so maximize this quantity, therefore we want to minimize this quantity subject to the constraints of these guys. And now we will have to add the variance multiplier. and also second constraint that basically people typically assume that the solution will saturate the risk, right? So basically they impose this constraint as an inequality. Okay, so we have our QUBO formulation of the problem of portfolio optimization. So with this, we have seen several examples in which practical and interesting problems can be mapped into a QUBO.